when we talk about dividing polynomials, this is something we actually even did in the very first videos we had, but we might not have called it dividing polynomials. What we called it was quotient of powers. We still have a fraction, we still have a monomial divided by a monomial, and in fact we can even look at leading coefficient of 15, degree of 10, constant of 0. We can still look at these polynomials now that we've expanded our vocabulary, but just like we did before, still what we've got here is coefficients, divide just like we would a fraction. Just like I were dividing those numbers, if I had 15 over 3, that's all fractions are division. Divide my coefficients. If I have x to the 10th, quotient of powers, subtract my exponents. X to the 5th power, 10 minus 5. Because remember, this meant I had 10 x's in the numerator, 5 in the denominator. We covered this the first day, just didn't call it that. Remember, what we want to do is divide my coefficients, subtract my exponents. It's almost the opposite of when we were trying to multiply, because that's almost what division is, the opposite of multiply. Next example, and for most of the examples that we're going to have in this course, we're just going to have dividing by a monomial. When we get into dividing by a binomial or any of the other methods, we're going to have synthetic division, some of these others. When we look at some of those long division, those are the kind of things we aren't going to see as often and won't be as valuable for us in this course. So for this course, we're just going to focus on dividing by that single monomial each time. Well, notice that when I have a binomial, all I'm going to do, just like we did before, distribute. And when I say distribute, I'm just going to divide both of those. If we really wanted to show the step in detail, 80x to the 5th over 2x cubed plus 6x to the 7th over 2x cubed. And when we divide these, what we're going to have is divide my coefficients, 40, subtract my exponents, x squared, plus divide my coefficients, 3, subtract my exponents, x to the 4th, and there's my solution. And notice it's not as critical that we have the order of descending power because they weren't an order of descending power up here. So just be clear that whatever they start the problem with, note that's the same thing they're going to expect for us. Now, as we look at a trinomial divided by a monomial, it's going to be the same exact idea. We're still going to distribute. We're going to divide each term in the numerator by the denominator. And again, this will not work, this type of idea, if we have a binomial in the denominator. We have a whole different method once there's no longer a monomial. But again, this is the only thing we're going to see. To show the fundamentals, x to the 4th over 3x plus 15x cubed over 3x plus negative 6x squared over 3x. Fundamentally, this is what we have going on. But let's look at the details here. Now, obviously, the one that's easiest is when everything's positive, when it divides evenly. Let's start with the easy one. 5x squared, divide the coefficient, subtract the exponents. Even when we have a negative divided by positive, not too bad. Ends up being a negative because different signs. 2, subtract my exponents, x to the 1st, but I just put x. Now over here, the one we wanted to avoid, because it doesn't seem to divide evenly, is actually the easiest of them all. Because notice that when we have an x to the 4th, remember my coefficient really is 1. Over here we actually had to think 15 divided by 3. Over here we had to think of not only division, but even with our signs. Over here, 1 over 3 is 1/3. It's perfectly fine to have a coefficient of a fraction. 1/3 x, still subtract my exponents. My coefficient, though, just happens to be that 1/3 times x cubed. And I do know that if we did have a fraction, we may need to reduce, but that just becomes my coefficient.